Hi. In acids, bases and salt chapter, I am going to discuss about dilution, strength of acids and bases, pH scale and its importance in our daily life. Let's start. What happens when water is mixed with acid or base? To know this, we need to perform one activity. For this, we need some materials. They are 2 test tubes, some amount of water, concentrated sulfuric acid and sodium hydroxide. Procedure: you just take 10 ml of water in a test tube, add few drops of concentrated sulfuric acid to it and swirl the test tube slowly and touch the bottom of the test tube. What do you feel? When you touch the bottom of the test tube, we feel hot. Is it an exothermic or endothermic process? It is an exothermic process as heat is liberated. Now, take 10 ml of water in another test tube, add sodium hydroxide instead of hydrochloric acid. Now swirl the test tube slowly and touch the bottom of the test tube. Now also you feel hot. Observations: the process of dissolving an acid or a base in water is an exothermic process as heat is liberated. Precautions: care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. The sign is displayed or printed on the cans of concentrated sulfuric acid and on the bottle of sodium hydroxide to indicate that they are harmful for us. This is a sign which we can see on the containers of concentrated sulfuric acid and sodium hydroxide pellets. Dilution: mixing an acid or base with water result in decrease in the concentration of H3O plus or OH minus ions per unit volume. This process is called dilution and the acid or the base is said to be diluted. To know the strength of acid or base, for this we need to do one activity. Required materials: 2 beakers, graphite rods, bulb, connecting wire and 230 volts AC supply. Procedure for acids: take 2 beakers A and B. Now fill beaker A with dilute acetic acid and beaker B with hydrochloric acid. Arrange the apparatus as shown in the figure and pass electric current through the solution in separate beakers. In one beaker, dilute HCl solution and in another beaker, dilute acetic acid solution. What do you observe? We observe the bulb glows in 2 cases, but the bulb glows brightly in HCl solution than in acetic acid solution. Can you guess the reason for the changes that you observed? Yes, HCl has more ions and CH3COOH has less ions. Observation: we notice that the bulb glows brightly in HCl solution while the intensity of the bulb is low in acetic acid solution. This indicates that there are more ions in HCl solution and fewer ions are present in acetic acid solution. Conclusion: more ions in HCl solution indicates that there were more H3O plus ions. Therefore, it is a strong acid. But acetic acid has fewer H3O plus ions, therefore it is a weak acid. For bases, if you do the same activity, now carry out the above experiment by taking bases like dilute sodium hydroxide and dilute ammonium hydroxide instead of acids The bulb glows brightly in dilute sodium hydroxide solution than in dilute ammonium hydroxide solution. More ions in dilute sodium hydroxide solution means more OH- ions, then it is a strong base. Dilute ammonium hydroxide has fewer OH- ions, therefore it is a weak base. Universal indicator. Universal indicator is a mixture of several indicators. It shows different colors at different concentrations of hydrogen ions in a solution. It can also be used to know the strength of an acid or a base. pH scale. A scale for measuring hydrogen ion concentration in a solution is called pH scale. To avoid the negative powers of H+ concentration in dilute acid and base solutions, Sorensen introduced the concept of pH. So this is a pH scale. The P in pH stands for potenge. In German, potenge means power. The pH scale ranges from 0 to 14. If the value is less than 7, then it is an acidic solution. Equal to 7, then it is a neutral solution. Greater than 7, then it is a basic solution. And if the number is from 0 to 3, then it represents a strong acid. 4 to 6, it indicates weak acid. 7 means neutral. 8 to 10, weak bases. 11 to 14, strong bases. As the number increases, there is a decrease in H3O+ ion concentration. Importance of pH in everyday life. Are plants and animals pH sensitive? Let's discuss. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, then it is called as acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. Is pH change cause of tooth decay? Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel, which is made up of calcium phosphate, is the hardest substance in the body. It does not dissolve in water but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth. The best way to prevent this is to clean the mouth after eating food. Using toothpaste, which are generally basic, neutralize the excess acid and prevent tooth decay. pH in our digestive system. We all know that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During indigestion, the stomach produces too much acid and this causes pain and irritation. To get rid of this pain, people use bases called antacids. These antacids neutralize the excess acid in the stomach. Magnesium hydroxide, milk of magnesia, which is a mild base, is often used for this purpose. pH of the soil. Plants require a specific pH range of the soil for their healthy growth. Activity to test the pH of the soil. Take some soil in a container and add water to it. Shake the contents of the container. Filter the contents and collect the filtrate in a test tube. Check the pH of the filtrate with the help of universal indicator paper. If the soil is acidic in nature, which is not suitable for agriculture, then the farmer would treat the soil with a base like calcium oxide, calcium hydroxide, calcium carbonate. If the soil is basic in nature, then the farmer should add acid to it to get proper yield. Self-defense by animals and plants through chemical warfare. A honeybee sting leaves an acid which is formic acid known as methanoic acid, causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of leaves of a nettle plant inject methanoic acid causing burning pain. A traditional remedy is rubbing the area with the leaf of a dog plant which often grows besides the nettle in the wild.